Next sensor is light sensor. Light sensors detect the presence of the light that is visible or invisible. Examples used for this is infrared sensor, photo detector, flame detector. Radiation sensors, they are the sensors detect radiation in the environment. So the radiation can be sensed by scintillating or ionization detection. Examples used for this is Ziegler-Miller counter, scintillator and neuron detector. Next sensor is temperature sensor. Temperature sensors measure the amount of heat or cloud. Temperature sensors measures the amount of heat or could that be present in the system. They can be broadly classified into two types. One is contact and non-contact. In contact, temperature sensors need to be physical contact with the object being sensed. And the second one, non-contact sensors do not need physical contacts as they measure temperature through convection and radiation. The examples used for this is thermometer for contact, calorimeter, then temperature gauge. Next is a chemical sensor. Chemical sensors measure the concentration of chemicals in the system. So when subject to a mix of chemicals, chemical sensors typically select you for a target type of chemical. For example, how much is a carbon dioxide is. CO2 sensor. This is only the carbon dioxide. Example what that is breathalyzer, olfactometer, smoke detector. Next is biosensors, where the biosensors detect the various biological elements such as organisms, tissues, cells, enzymes, antibodies and nucleic acid. For all these, the different sensors are going to be there. Examples: blood glucose, biosensor, then pulse oximetry, and electrocardiograph. There are so many sensors now we studied. One of the example that shows on your screen, that is power of sensors and IoT, is in the area of precision agriculture. So when the farming is going to be done, so for smart farming, these sensors are going to be used. They are called as biodegradable sensors, developed by NDSU for smart farming. Here, these sensors, what is this sensors? They are going to do it. These sensors development is mobile phones. You can use it. Then smart homes, for potentially hundreds of sensors are going to be available. Then intelligent vehicles with hundreds of sensors are going to be available, and the cities with thousands of connected sensors. And as a sensor, they are available in cheaper rate. So sensors can be used for the applications and used for the peoples, which they want to use it for the proper execution of the applications. Now you will be able to see in the middle there is a smartphone. So there are so many sensors are going to be there in this smartphone. You can able to that is NFC is there, that near field communication. Then proximity sensor is there. Then we have magnetometer, which it uses for the compass. Then we have accelerometer, humidity sensor meters, check for the humidity, gyroscope, moisture sensors. By using the IoT, that it is possible to make it all these things. Then we have a microphone is there. Then fingerprint sensors are there backside to that phone. And digital biometric sensor is going to be there. You can use it. Then thermometer. Again, connect basically. These things are going to get connected for that actually. Then touch sensors are there. Light sensors are there. Then GPS system, global one positioning system it is. Then we have pedometer, what is the calorie that you will be going to burn, and my steps that you will be going to make in a day, everything. And finally the camera is a fantastic tool. It is going to be used in the smartphone. So many n number of sensors are going to be present. There is very less it has been given here. However, that you go to the market, you can buy n more features. Phones are going to be available on the is what we are going to say that sensor very cheap it is going to be. That's what it's saying. The sensors are available in a cheaper rate. So the people are going to use for their applications. Now, according to this process, there is a growth in predictions in the number. So by 2037 or 2032 to in between that, the sensors are going to be, how much you can just see that. Okay. How much it is? Very big number it is going to be. So by seeing that, the sensors are going to be used for more number of applications. Now, the sensors are going to sense and the data is collected, and what next? Next is actuators. Actuators are natural components to the sensors. The actuators will receive some type of control signals, commonly the electric signal or digital command, that triggers a physical effect, usually some type of motion, force or so on. Here it is being given here. The diagram, it shows that real world physical environment is there. Another is a digital representation of the electric signal. The sensors are going to sense and measures. Sensors are going to sense and measures. Actuators act and for useful work. And another very clear information is going to be here. The comparison is what is sensor and actuators. You can see the human are going to be, the sensors are going to be there in the human, that it is going to be fed to the CPU, isn't the brain. So in the sensors you are going to have nose, ears, eyes, hands, mouth. So these sensors are going to sense, and it is going to be sent to the CPU, which is going to be called as the brain in the human, and actuate